way everybody has a rough test, but if you show me that your overall understanding is pretty high, then I can replace that. But I'm not going to penalize you any more than the final already penalizes you. Because if you do poorly on the final, you get penalized because it counts towards your grade. So I'm not going to like double penalize you if it's lower. Yeah. Right. Yeah.
So that's just for the last two exams too?
For the regular exams. Yeah. It's not with the quizzes or anything. It's just the regular exams. Yeah, the two that you took in class.
Okay.
Yeah. Okay. So, anything else? All right. And the practice test is out there, so hopefully you've had a chance to at least see it. It's down there. It's just the last module. It's like preparing for the final or whatever, and you can get the practice final on there. And it's kind of similar to what you'll see on the test.
Exams next week?
No, it's during finals week.
It's not like the fourth, right?
Yeah, it's like that Thursday of finals week. It's actually quite a ways away. Yeah, there's next Thursday's Thanksgiving, and the Thursday after that is the final.
So we don't have school Wednesday or Thursday
Yeah.
next week, and after that we come back and we start taking finals.
Yes. Yes, that's correct. All right. Yep. So there's a pretty big gap. That's why we're talking about meeting that Monday.
Last week's
Yeah.
school, so.
Yeah. Yeah. This is a weird.
Well, not really needed last week,
The
It's a good thing I've got those good grades.
The good thing is that the other thing is like it's kind of rough, but also in the spring it's the opposite problem is because everything's just like crammed in together that everything goes really fast. So like in some ways it's better to have it drawn out, but in some ways it's better just to condense it because then you don't get as much time in between. Oh, summer's super condensed, yeah.
Yeah, that was just crazy. I was just like, dang, there's like I say every day. And there's
Yeah, summer's nuts. All right, so yesterday I handed out those problems. They had the examples of, how these equations can be applied. Making sure my recording was going. All right, and this one though, they actually had already formed the equation for you, right? So like the first one, they talked about concert tickets. So at a school concert, they give you a total value for that was sold, and they tell you how much each costs. Then they give you a relationship between the two variables, right? And they tell you that 5 less than 3 times the number of student tickets is how many adult tickets they sold. And then they give you an equation, okay? And they say, okay, 6s plus 9 times 3s minus 5 equals 1,506. All right, so what is s in this equation? What does that little s stand for in this? Yeah, it's the number, right? S equals the number of student tickets. So a lot of times when you're going to solve application problems, it's nice to pick variables that actually kind of help you remember what they are, right? So S makes sense because it's student tickets, right? So what is this? What is 6S then? Why is there a 6S in that equation?
Student tickets for $6?
Yes, right? Because this is like $6 times the number of students. Yeah? And so then in other words, what is this going to tell us? This is going to tell us the money that they earned from the students, right? That's what the 6S term is. It tells us how much money they earned. That would be the money they earned from the... Now, what is this? What is 3S minus 5?
5 less than the number of 5 less than 3 times.
Mm-hmm. And so together, that whole term, that's the number of what?
That's the number of students.
No, the number of student tickets they sold is S. What is that 3S minus 5?
Oh, the adult tickets.
Mm-hmm.
That were sold.
So this is the number of adult tickets. So there's only one variable here, it's student tickets, but they told us the relationship between student tickets and adult tickets. They told us that the number of adult tickets was 5 less than, that's the left minus 5, 3 times the number of students. So this is the relationship between the two. So then this whole term right here, what is this whole term right here? then? Why is there a 9 there?
Adult tickets sold for $9.
Exactly. So this is $9 times the number of adults. And so this whole term is the money, right, that they got from adults. Yeah. There's more of the, in case anybody, I'd put the extras back there in case you wanted, but okay. So then this is how much, the first term is how much they made from students, the second term is how much they made from adults. And then together, why do they have a plus? And what's this? Why is it plus and then 1506? Because what?
It's not added up.
Yeah, the two of those together meet the total that they brought in. Yeah? So it's like the cost, the money they earned from students plus the money they earned from adults is equal to the total amount of money they earned. The money they earned from students, we don't know what students are yet, but we know that it was $6 for every student. And the number of adults, we don't know that either, but we know the number of adults was related to the number of students this way, and they got $9 for each of those. Yeah.
So like, if we were to, so we wouldn't be able to combine the like transport, the 6S and the 3.
Well, that's how we should. So that's how we should proceed from here. But you have to be able, here's the thing though, is because this one provided you the equation. But it's important to understand why they constructed the equation that way. Because you can be like the best equation solver in the world, but if you don't know how to take the problem and turn it into equation, then you're kind of like stuck in the water, right? So now we should solve it. Yeah. But I wanted to spend some time going over like how each term was created.
Yeah, well, I just was wondering because like if you were to combine 6S and 3S, so wouldn't it be different technically because two different prices?
Well, that's right. Well, but see, we can combine them, but why can't we combine those terms yet? We can't combine that 6S and that 3S term because why? Because it's in parentheses, and so what do you have to do?
You have to distribute.
Right.
You get it out of parentheses, but.
Yeah. So then,
What I'm saying, because the adult tickets are $9,
yes,
and then the student tickets are $6,
yes.
so they're technically not the same.
Well, yeah. Oh, yes, true. Yeah, that's why they need to be in different terms. Yeah. Yeah. You can't combine these. That's true. But you can, once you create the equation, though, you can combine your S terms if you use the distributive rule to get rid of your parentheses. Okay. So then now,
Okay, alright, I get it.
yeah, because now we could combine these. So 6 plus 27 is 33S. Okay, and then we can actually solve this one because what's the next step here? What, add? Right? Add 45, add 45. So you'll get 33S, and then this is 1551. And then if you divide by 33, well, what's 1551 divided by 33? 47. There you go. What is S? But what does that actually, what does that number mean? Because this was in context. What's
47 tickets sold?
to who? Yeah. Yeah, so there's 47 student tickets. Could you solve for the number of adult tickets if you needed to? You could, right? Because we know the relationship. So we could get the number of adult tickets by just plugging in 47 into that relationship. So 3 times 47, that's what, 141? And then you take away 5, and then 141 minus 5 is 136. So then that would be, so there's 47 students and 136 adults. Yeah. And could you check the answer if you really wanted to? Sure, right? You could just say, well, there's $6 for every student plus $9 per every adult, and then calculate them out and make sure that 6 times 47 plus 9 times 136 adds up to 1506. And if you check it, it does. So then you say, oh, okay, perfect. Now this one in particular just wanted the number of students. So you didn't, this part right here, I didn't ask you for that part right there. Yeah, that, I didn't really ask you for that in that problem. But you would, if you wanted to check your answer, you'd have to get that part. Because to be able to go back and check your answer, you would, well, you could plug it back in that if you wanted to. But it's a little, I think it's actually easier just to figure out the results and check that. But it only asks for one variable. That's true. Okay, questions on that one? What do you think? All right. The next one is talking about a fencing example. So it's dealing with perimeters, and the reason it's what's going on here is like if you have a rectangle, right, and you have a length and a width, and you want to calculate the perimeter. Okay. Well, perimeter is just the distance around, right? So that would be length plus length. So there's 2 lengths, and width plus width is 2 widths. So the perimeter rectangle is like 2 lengths plus 2 widths. So then they said that Micah has a certain number of fencing to make a rectangular pen, but he wants the length to be 25 feet more than the width. All right. And so what's happening here is there's a relationship. So now he's saying he wants the length to be, what, 25 more than the width, right? So then the width is, you can think of the width as W, so then the length is going to be W plus 25 more. So if you look at the equation that they set up, there's a 2L and a 2, oh, they did it in terms of L. Okay. So why do they have a L minus 25?
Because the length needs to be 25 more.
Yeah, the length is the longer one. So then the width is the smaller one, right? So another way to think of this would be that the width is the length minus 25. You could actually think of them both in terms, you can think of either one in terms of the other. The length is 25 more than the width because the length is the bigger one, or the width is 25 less than the length because the width is the smaller one. So you can go either way. So then the reason the way they came up with this is this right here is their W. So you can kind of see how they're like substituting in L minus 25 for the width in the formula, and then 74 is the overall perimeter. That's the perimeter all that. So there's 2 lengths, and then there's 2 widths. So the widths are 25 less than the lengths, and then they total the perimeter, and then we can solve this. So this one, to solve it, you just do distribution. So it's 2L plus 2L minus 50, right? So then this is 4L, and then you would add 50 to both sides, yeah?
Yeah.
So that would be 124. Divide both sides by 4, and you'll get 31. What's the units here? Feet. That's the length.
Do we have to have the units on the images, or will we get marked off?
Yeah, you should include units in problems like this because there are units.
The only units that it gives us is feet.
Yeah. So the feet should be part of the answer. We know the units in this case.
But if it doesn't give us units, then we don't have to.
Yeah, I mean, right. All right. Questions about that one? Okay. So then the next one is like a money problem. Money problems are pretty common. And it's just another way to show the relationship between items. So it says there's $2 in dimes and pennies. The number of pennies is 2 more than the number of dimes. And then they give you this equation. So they have this 0.10 D plus 0.01 D plus 2. equals 2. All right. So what does this term represent? That first term, 0.10d. Yeah, right? This is, and it's because what? They're worth 10 cents each, and there's D dimes, right? So then this total, this is the value of the dimes, right? Then, well, what's this? Why is it 0.01? Because the pennies are worth 1/100th of a dollar. And why is there a D plus 2? There's 2 more pennies than dimes. So that term is the value of all the pennies. Okay. And then together, what do they add up to? Well, they add up to $2. And that's why it adds up to 2. So we could, how would we actually solve this? What do we need to do? We need to get rid of those parentheses. So we've got 0.10d. If you distribute that, it's 0.01d. And then 0.01 plus, or times 2 would be 0.02. All right. And then you could combine your like terms. So that'd be 0.11d. Then you could subtract the 0.02 from both sides. So you can do that in your calculator. It'll be $1.98, right? Because it's $2 minus 2 cents. And then you can divide both sides by 11 cents. And then you'll get some answer, which I don't know what it is, but I'm guessing it's, is it 18? Okay. And what is D? Yeah. There you go. So there's 18 times, and there's 2 more pennies than that, so that would be 20 pennies. 18 times 20 pennies. Which makes sense because 18 times would be $1.80, and 20 pennies would be 20 cents. And together that would make $2. Yeah.
Cool.
All right.
So where'd you get 198 again?
What I did is I subtracted the 0.02 from both sides.
So would that work if you went like 0.11d divided by 0.11d and then divided 2 by 0.11d and then
If you divide, you have to also divide this term by 0.1. Is that what you're saying from this point?
yeah, from like that point if you just went
You'd have to divide all the terms by 0.1.
oh, okay.
So you can do that, but
But you have to do it all and then be
Yeah.
extra step.
you can't. Yeah, exactly. You can't just like pick some of them to divide and some of them not to divide. Yeah. Oh, it's distressing? Yeah. All right. Cool. Yeah, so I'll usually towards the end of the term, I'll usually start kind of maybe not filling in all the steps, but if you ever have questions about where one of the steps are, just let me know and I can fill it in. But ideally, hopefully we're getting to the point where we can kind of fill in some of those ourselves. So.
On the
Yeah.
quiz,
Yeah.
are you gonna have the formula already?
No, see that's the thing. This
We
is
have to
just
figure out
that's
the
the
formula.
yeah. This is really just kind of like an introduction to how these formulas can be applied to the applications. But
Have like more practice.
yes. So what I got is a bunch of practice for you today of problems where I'm not going to give you the equation and you get to try to construct it yourself. That's the idea. Okay. So let's finish our last one here. So then Travis bought some stamps. The equation they give you is 0.49s plus 0.21 s minus 5, and they add up to 9.45. Okay, so why do we have a 0.49 here?
Because that's the 49 cents
Yeah, there's 49-cent stamps, and so then S must be the number of 49-cent stamps, right? Okay. So then the other 21-cent comes because, well, those are 21-cent stamps. And then why S minus 5?
Because he bought 5 less.
Right, exactly. There's 5 less than the number of 49-cent stamps. That's what the problem says, right? Okay, so then this right here, this is the value of the 49-cent stamps. And so then this term right here, this is the total value of the 21-cent stamps. And then together, they should add up to how much he actually spent. And then that was 945. Yeah? All right, so then if we were actually, now we could actually solve this. But once you, once you have the equation, solving it's not really the hard part, you know. So we'll just distribute, it's just like the last ones. So that'd be 0.49s plus 0.21s minus 5 times 0.21, I think is 1.05. You should check that for me, but I think that's right.
Yeah.
Okay. Perfect. And then these are like terms. So your S terms would combine to a 0. You can plug in your calculator, but I think it's 0.7 S.
Yeah.
All right. Then you'd add the 105 to both sides. So 945 plus 105, that's 1050. And then you would divide both sides by 0.7, and then 1050 divided by 0.7. I don't know what that is.
292,857.
That hopefully is not right. Yeah, it should be even. Make sure you. Yeah, I was hoping to be 15.
So we do 15.49 cents.
Yeah, so what are the units on there? There's 15 49-cent stamps.
Oh, so yeah, I guess it would be 15.
Yeah, it should divide out as a whole number, hopefully, because you can only buy whole number amounts
For
of
some
stamps.
reason, I got 10.45.
Yeah. Oh, you didn't add the extra 0.05 because it was 1.05.
1.5, yeah, that's right.
Mhm. Yeah. Okay. So now the hard part is actually constructing the equation. So I'll give you an example. So let's say that for a meeting, you're going to cater lunch, and maybe the people have an option of what they can choose. So let's say you cater lunch for, say, I don't know, let's say like 16 people. Wait, is that what I want to do? Maybe this is a bad example. Why is this not looking like how I want it to look? It doesn't really matter. Okay. Well, maybe it does matter. This one is actually kind of interesting. You can do this, but here's how you can. Okay, so let's say each can choose from, say, either say a salad, and let's say the salads are $8 each, or a sandwich or something, and let's say that the sandwich is $10. Let's say $7 each. Doesn't actually matter. Okay, and so then let's say that the total bill was. Now this part I got to make it up, so you got to give me a second. Let's say the total bill was. $119. So let's say how many of each were ordered. Okay. And hopefully I did that math right. I might have messed it up, but we'll know if it comes out with decimal amounts of people. But. All right.
This is that 8.3 to 8.4 factors? Like extra factors?
No, this is actually getting into chapter 9 because chapter 8 really focuses all about solving equations, and then chapter 9 just really focuses on how you can apply them to solve problems. Okay. All right, what do you think?
So like, we would probably start by saying 16, because that's the first.
So there's there's 16 meals total. Yeah.
Yeah, total. And then we'd do like.
Yeah. Actually, here's one.
19 divided by.
How about this? How about I ask this question? Maybe this will help us frame it a little bit. How many? Let's just say maybe not how many of each. I would just like to know one. Let's say how many salads were ordered. But we can still start in the same place. Okay. How many salads? All right. Yeah, so there's 16 meals total. We know that much. Now, what has to be true? What do we need to do? If we're going to try to frame in some equations like this, we need to pick what? What's in all of these equations? Numbers and variables. Yeah, letters, variables. And so typically when you're solving a problem, you can follow some steps. I'll write the steps down in a second. But the first step is obviously read the problem. The second step is you want to try to assign some variables here, some letters. And I say, okay, well, what are we trying to actually find? Number of salads. So let's give it a letter. What letter do you want to give it? S is a great letter, right? So let's say S is equal to the number of salads. Great. And then how much do salads cost? They cost $8 each. Okay. So we can start to think about building our equation, and this is kind of like a couple of these examples, right? So you say, okay, well, that's the number of salads, but what's the relationship between the number of salads and the number of sandwiches? What has to be true?
That it equals 119.
No, the number of how many people were total. See, so that's where this comes in. Okay? So, like for example, if there were 10 salads, how many sandwiches would there be? 6. Or if there was 8 salads, there would be 8 sandwiches. They have to add up to 16. Well, how could you say that? How did you get the answer for the number of sandwiches when I told you the number of salads? You subtract. Yeah. So the number of sandwiches is like 16 minus the number of salads. Okay. All right. And how much do sandwiches cost? They're $7. So we can start building an equation like the ones we saw where it said, okay, well, you think about the number of salads, and they cost how much? $8. And then you tack on the number of sandwiches, and how much did they cost? $7. And then together, they should add up to what? The total cost of the plates or whatever. Okay? So it kind of has a template in a way. It's like how much one is worth times how many of them there are, plus how much the other is worth times however many those are. But usually the second term is in terms of the first. So they both have S's in them. So we could solve this now and see if we get a reasonable answer. See if I made it up right. So 7 times 16 is 112. Is that right? 7 times 16?
Yeah.
112. And then 7 times S would just be, so this would be minus of 7S. Oh yeah, this is going to work out nicely. So what's 8S minus 7S? Just 1S. And then we just subtract 112 from both sides, and it looks like S is 7. which means how many sandwiches must there have been? 9. And you could check that to see if it works, because you could do 7 times 8 plus 9 times 7 and make sure it adds up to 119. And you get the right answer. All right. What do you think about that one? I'm making up another one while we think about it. Questions on that one? No? All right. Go ahead.
How do you go from 8s to 7s that's plus 104? And then we go like plus 7.
Well, these are like terms.
So you would just combine
Yeah.
all the one S?
Yeah, because there's 8. Yeah, exactly. Because there was 8 S's, you subtracted 7 of them, you only have 1 S left.
Oh, okay, and that's showing us just S. Alright.
Okay.
Yeah.
All right. All right. You want another one?
Yeah.
Okay. Any questions on that one? This one. All right. So let's do one of the ones with the money, because that's kind of interesting. So let's say that you have only nickels and quarters. So you have only nickels and quarters in your pocket. And let's say that you have, say, 3 more quarters than nickels. And a total of 435 and change. So I'd like to know how many nickels do you have, say? What do you think?
So like going off what you just say like, so nickels would be just call that like N.
Yeah, so start by giving a variable. That's a great place. And you say, all right, so in we would call as the number of nickels. Sure.
And that would be minus the number of quarters.
Now, yeah, so the quarter, is the number of nickels bigger or smaller?
Smaller.
Yeah, and so, so then the number of quarters would be what?
Would be
Bigger or smaller? Yeah, bigger, right?
plus N.
Yeah, so you have more quarters than you have nickels, and you have 3 more, so it's going to be plus in this case. Yeah, addition. All right. So now we can kind of use that template for constructing the equation that we've seen before on our practice from yesterday and even our last one. It's going to be like, okay, well, nickels have a value, quarters have a value, and together they add up to a total. So then how could we start constructing our equation? What's it going to look like?
Would be N plus 3.
Yeah, times what? So there's going to be an n plus 3 in there. That's true. And that's the number of what?
That's the number of quarters.
And how much is a quarter worth?
Quarters are 25.
Yeah, so that would be like 25 cents for all your quarters. Then there's also your nickels. How much is a nickel worth? 5 cents per nickel. And together, how much do you have? 435. Yeah. So this is the equation that you could set up to solve the problem. You have n nickels, and they're worth 5 cents each. You have n plus 3 quarters, and they're worth 25 cents each. And then together, you have $4.35. Yeah. And that's the hard part Now you just have to solve it. So then this is what, 0.05. Go ahead.
So the value of the nickels, we're timesing it by the amount of nickels.
Exactly, yeah. Because we're trying to get the value, because ultimately what we know is the value, the money value. So this is the money value of n nickels. This is the monetary value of that many quarters. And then together they add up.
Nickels are less than the 3 less than the quarters.
Yeah, but so there's two. That's the thing about setting these equations up. It depends on which one you're solving for, because if you were solving for quarters, then you know that the nickels would be quarters minus 3. But if you're solving for dime or nickels, then you know that quarters is and plus 3. You know, so it just depends on which one you're actually solving for. All right, so then if you distribute the 0.25 through, you know, you get 0.25 in, and I think times that is 0.75. You can combine your like terms. So that's going to be 0.3 n plus 0.75. Then you'd subtract 75 cents from both sides. So this minus 75 would be what, 3.6? And then you divide everything by 0.3. And I think you'll get 12. And n is 12, and that is nickels. So then how many quarters would you have? 15. And then you could go back and check, and you say if I had 12 nickels at 5 cents each, that would be 60 cents. If I had 15 quarters at 25 cents, that would be some other number I don't know off the top of my head, and hopefully they add up to 435. 15 times 0.25, so 375. 375 plus 60 cents should be 435. All right. What do you think? Questions on that one? Then I got another one for you. This is a fun one. We'll try one more fun one. Oh, that's not what I want to do. Let's go. And then I got some practice problems I'll hand out to you. So let's say that 2 consecutive integers add up to let's go bigger than that. I want 151. Find the 2 numbers. What do you think? There's actually an easy way and a hard way to do this one, but the formulaic way will always give us the answer. What does consecutive integers mean? What are the integers? Yeah, one after the other. And which ones are the integers? Yeah, but just in terms of actual numbers, what types of numbers are integers? They're like counting numbers, but they include positives and negatives. Although here we're probably only looking at positive ones because they add up to. Yeah, so they're whole numbers, right? Whole values. And so 2 consecutive integers add up to 151. What are the 2 values? So again, I would try to solve some, I would try to put some letters to this, right? And here you could use an N or you could use an I or X. It doesn't really matter, right? But let's just call, sure, we'll just call X. So there's 2 numbers, right? So there's a first number and a second number. And you just got to pick one to be X. It doesn't actually matter which one. But let's say X is going to be the first number, right? Well, then the second number would have to be what, bigger or smaller than that one? So it'd be the next one. And how much bigger would it be if they're consecutive integers? It'd be 1 bigger.
So it has to be bigger?
You could go the other way and let it be the smaller one. It doesn't actually matter. Yeah, it doesn't.
It just has to add up to 1.
Yeah, so you could think of if your bigger number is X, then your smaller number would just be X minus 1. It doesn't matter which way you set it up. The difference is that if you solve it our way, we're going to get the small number first. And if you solve it the other way, you'll get the big number first. But then the other one's going to fall out. All right.
So you could go X equals the first number, and then you could go Y equals the second number.
But the key is you don't want to introduce more than one variable. You really want to keep it in terms of one variable, because one equation with two variables you can't solve. You can't solve an equation in two variables. So you want to keep it to one. So then the way you figure out, you say, okay, well then that means that the first number plus the second number have to add up to 151. All right, well then these are like, we really actually don't need the parentheses here because there's no multiplication. So we can just combine our like terms. This is just 2x plus 1 equals 151. So we should probably subtract 1 from both sides. And then divide by 2. So it would be 75, which means the number after that is 76. And so if you add 75 and 76, then you get the answer. Yeah?
Why is it 150?
Because from our equation, so when I combine my x, I got 2x plus 1 on this side, so I had to get rid of that 1. So I subtracted 1 from both sides. And so that's how 151 comes up in the next step. Because we took away 1 from both sides. Yeah?
Yep.
Question? No? Good. You don't have to do it that way. No. No, you could set it up the opposite way. Or this one's kind of, you can kind of cheat on these ones because there's two numbers right next to each other, so they've got to be pretty close to the same size, but they're adding up to 151, so you know the numbers have to be about half that. So you could just divide 151 by 2 and then figure out the numbers on either, you know, around that area, and then you could just kind of guess and check. That's an option. So, all right. Any other questions? All right. Sweet. So I've got some. So I have two for you here because this kind of these two sections 9.1 and 9.2 they more or less cover the same stuff. One of them focuses more on just like solving problems in general, and the other one focuses on money applications. So I'll just, there's not that many people. I think what I'll do is I'm just going to put them back here, and you guys just grab one of them, cover that. So go here, grab one of each, and I gave you, on the first one, I kind of gave you the steps that I typically follow to solve problems like these. And then today and tomorrow, all we're going to do is I'm going to be doing more practice time on these. So I'm going to let people work on these a little into the beginning tomorrow, and then we'll spend the second half of tomorrow going through the answers on these. Because I want people to at least give them a shot.